Hello and welcome to PH Physics. Today's explainer is the generator effect. Spinning a coil in a magnetic field induces a voltage. By the end of this video, you'll know how every power station works. The generator effect is the induction of a voltage by rotating a coil of wire in a magnetic field. As the coil rotates, the magnetic flux through it changes continuously. By electromagnetic induction, a voltage is induced. If connected to a circuit, current flows. Slip rings or a split ring commutator transmit the current to the external load. Three things. 1. AC generator uses slip rings and the output is alternating. 2. DC generator uses a split ring commutator, so the output is direct. 3. The energy source spinning the coil could be steam from coal, gas, nuclear, or wind, water, tides. A common slip is confusing the generator effect with the motor effect. Motor effect is current to force to motion. Generator effect is motion to voltage to current. Same physics, just opposite direction. Quick example, a wind turbine spins a coil between magnets. As the coil rotates, the flux through it changes. Voltage is induced and the current flows down the cables to the national grid. Every gigawatt of generated electricity uses this principle. Right, if any of this is going to stick beyond this video, drop into phmaths.com. You'll find a free 4-week GCSE higher revision planner ready to download, plus the mastery workbooks. One for every higher topic, every answer fully worked, every common slip flagged. Simple explanations, serious results. See you next video.